Atwood machine is an application of Lagrangian equation. Here we see how this is a frictionless pulley and it is a string whose total length is L, and there are two masses M1 and M2 which are attached at the end of the string. Here M1 is less than M2, then M1 will move downward due to its weight and M2 will move upward. Here we use Lagrangian equation as partial L over partial Q dot, which is generalized form d over dt minus partial L over partial Q equals to 0. Or in terms of x, our Cartesian components can be given as d over dt partial L over partial x minus partial L over partial x equals to 0, which is equation 1. Now suppose that length from this point to this point is x, then from this point to this point will be L minus x. Here L equals to T minus V, where T is kinetic energy 1 over 2 m v square, or 1 over 2 m x dot square. For this case 1 over 2 m1 plus m2 x dot square equals to T, equation 2, and V equals to potential energy, which can be given as mgh, and for this case as m1, this mass is moving upward, so here we g minus g, and it's x minus m2 g and L minus x. V equals to minus m1 gx minus m2 gl minus minus plus m2 gs, and equation 3. Put equation 2 and 3 in equation. Suppose alpha, we have L equals to 1 over 2 m1 plus m2 x dot square minus and minus plus, so m plus m1 gx plus m2 gl minus m2 gx, and say it equation 4. Now take its partial derivative with respect to x, and we have partial L over partial x dot, and we have 1 over 2 m1 plus m2 and 2x dot, and these are constant terms, or it will be cancelled. We have m1 plus m2 into x dot. Here we have equation 5. Next, taking derivative with respect to just x, we have constant, and here we have m1 g plus constant minus m2 g. Taking common, we have m1 minus m2 g, equation 6. Now put 5 and 6 in equation 1. We have d over dt m1 plus m2 into x dot equals to m1 minus m2 into g, and taking derivative m1 plus m2 x double dot equals to m1 minus m2 into g, and x dot equals to m1 minus m2 g divided by m1 plus m2, which is acceleration of masses produces in Atwood machine.